Good morning, my YouTube viewers. It's Crystal here. I'm just here because I want to give you a code review on Kaggle's July 22 tabular competition. And basically what it is, it's an unsupervised competition, and it's their very first unsupervised competition. I made my script, and I got a 51.8% on the script being my best score. And so I got a bronze medal on it as well, but I'm not really going to make a video or a blog post on the bronze medal because I had to borrow the model from somebody else, and I just don't feel that it's right that I make a video or a blog post on the bronze medal that I got when I had to actually borrow the model from someone else. But I'll go ahead and do my code review. I will say that it was a very large data set, and what happened was they didn't tell you how many clusters it was. And so you just had to guess how many clusters it was. And I wasn't very happy with that because there are algorithms out there like the hierarchical and the DB scan where you can run it up without knowing how many clusters there are, and then it will just pick the clusters for you. But because the data set was so large, I believe it was like 98,000 rows. Something like that. Yeah, the train set was 98,000 rows. It was such a large data set that if you tried to use the hierarchical or the DB scan, it would crash the system. And so because of that, I didn't know what to do because I wasn't able to use the most appropriate model for the job. And as a result of that, I had to go into the code that people have kindly made public and look and see if I could find some code that would work. And so basically what you had to do was you just had to guess, so I guessed that there were seven clusters of data, but I'm not happy with that because I feel that Kaggle should have made the data set small enough to where we could use like hierarchical or DB scan if they were not going to tell us how many clusters of data there were. And because of that, because they made the data set so large that it crashed the system, I had to borrow somebody else's code, which I'm not happy with. So nevertheless, I'll go ahead and do the code review. I'm not going to do a blog post or a video on my bronze medal because I'm not really happy with this. They should have made it small enough where we could have used hierarchical or DB scan. So here's your problem statement. It says, welcome to Kaggle's first ever unsupervised clustering package. In this challenge, you are given a data set where each row belongs to a particular cluster. Your job is to predict the cluster each row belongs to. You are not given any training data, and you are not told how many clusters are found in the ground truth labels. So there you go. That's our problem statement. So the first thing that we wanted to do was we wanted to import the libraries. And so we started out with importing NumPy, which it helps you calculate numerical computations, create NumPy arrays, and do linear algebra. We're going to create pandas, which enables you to create data frames and maintain them, and also do data processing. Import matplotlib which is a graphics package which enables you to plot the data points onto a graph, and import Seaborn, which is a higher level graphics package made on the back of matplotlib, and enables you to do statistical calculations with your graphics. And then what we're going to do is we're going to code our file. We're going to use the load our file. We're going to use the OS library to do that, to go into the operating system and retrieve the files that we're going to be using. And we're retrieving data file and sample submission. And after we have loaded our files, we're going to use pandas to read the files. We're going to be using read CSV function. So we're going to read the data function, the data CSV file, and the sample submission CSV file. And I made it so you can see all of the columns. So there are 30 columns, 98,000 rows of data in 30 columns. And I put this bit of code in here, pd.setOption display.max columns none, so you can see all of the columns. Okay, and this is your submission file. That's what Kaggle wants to see when you submit your predictions. So I'm going to analyze the data, and so all of the columns were numeric, so that's good. You didn't have to ordinal encode anything. And then we're going to describe the data. So it tells you the count, 98,000, mean, standard deviation, min, 25%, 50%, 75%, and max. We're going to check for null values. You don't have any null values, so you don't have anything to impute. We're going to normalize the data, and when you normalize the data, what you do is you convert all of the data points to a value between 0 and 1. We're going to drop the ID because it's not necessary. So now we only have 29 columns. We're going to create a heat map. So this is the heat map that we created. And now we're going to remove columns that have a high correlation. But unfortunately, none of the columns had a high correlation, so we didn't remove anything. We're going to check our null values again, and so that's 0. So now we're using BayesianGaussian mixture, and that's what I had to borrow from somebody. So I'm not very happy with this. So BGM equals BayesianGaussian mixture, and components equals 7. So that means it's going to have 7 clusters. Covariance type equals full. Max iters equals 1000, and random state equals 42. Predictions equals BGM fit predict data, and then these are your predictions. We're going to use principal component analysis, and then what the principal component analysis does is it reduces the data frame down to 2 features, which allows you to plot it on a graph. So that's what we've done. So df equals pd data frame x is reduced data 0, colon to 0 is 0, y reduced data colon 1 is clusters prediction. So basically you're using a 0 column and the 1 column. And now we put it on a scatter plot, so you can see it on a scatter plot. SNS.scatterplot. X equals dfx, y equals dfy, u equals df clusters. Let's see if we've got something over here. So clusters equals predictions. So U equals clusters. So your predictions are your clusters. And then so these are the predictions, and it's on a scatter plot that's got seven different clusters. And then you got a bar chart. So space or dash counts equals NP unique predictions, return counts equals true, SNS bar plot equals list range 7, and then count. So we made a bar chart of the 7 clusters. We prepare our predictions. Submission predicted equals predictions. Submission to CSV equals CSV. Submission.csv. Index equals swap submission. And so this is what I submitted to Kaggle. And I'm not really pleased with it because I had to borrow the model from somebody else. And so that's it really. I hope you enjoyed this code review. I will leave a link to my notebook in the description box down below, so you can look at it if you want to look at it. So I'm going to go ahead and conclude this video. I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. Thank you so much for watching my video, and I look forward to making more videos for you in the future.